Welcome! Today, we are going to work through the worked solutions for the IGCSE Extended Mathematics Specimen Paper B for 2025. This is Paper 4, the calculator-based extended paper. Our objective for this session is to provide clear, step-by-step solutions to every problem on the paper while highlighting common pitfalls to avoid. Before we start, remember the general instructions. You must show all your working clearly to gain full marks, and for non-exact answers, always round to 3 significant figures, unless the question says otherwise. Let's jump into the first few questions on page 3. Question 1 asks for the reciprocal of 0.35. The reciprocal of a number is just 1 divided by that number. Using your calculator, 1 divided by 0.35 gives us a recurring decimal. Remember the instruction to round to 3 significant figures. So, the final answer is 2.86. Common mistake. Thinking reciprocal means negative or just changing the sign. Always remember it means 1 over the value. Question 2 is a straightforward calculation. When typing this into your calculator, it is safest to use the fraction button or put the numerator and denominator in brackets. The top part is 14.1. The bottom part is 0.6. 14.1 divided by 0.6 gives exactly 23.5. The answer is 23.5. Now, let's look at question 3, which involves ratios and percentages. We are told Naveen and Esther share money in the ratio 5:7. For part A, we need to find Naveen's share as a percentage of the total money. First, find the total number of parts in the ratio. Naveen has 5 parts out of 12. To turn this into a percentage, we multiply by 100. Using your calculator, this gives 41.666 recurring. Rounding to 3 significant figures, we get 41.7%. In part B, we find Esther's share as a percentage of Naveen's share. This is a common point of confusion. The total is now Naveen's share, not the overall sum. Esther has 7 parts, and Naveen has 5. This equals exactly 140%. Finally, for part C, we are told Naveen's share is $160. We need to work out Esther's share. Since Naveen's 5 parts equal $160, let's find the value of 1 part. Esther has 7 parts, so we multiply 32 by 7. The answer is $224. Common mistake. In part B, students often divide by the total parts instead of Naveen's parts. Always read carefully to see what the base of the percentage should be. Moving on to page 4, we have some algebraic simplification and an equation to solve. In part AI, we need to collect like terms. We have 5x squared and we subtract 1x squared. Then we have negative 7x plus 6x. Putting it together, we get 4x squared minus x. For part 2, we are dividing fractions. Remember the rule: keep, change, flip. We keep the first fraction, change division to multiplication, and flip the second fraction. Now we can simplify before multiplying. The y on the top and bottom cancel out. 9 divided by 3 is 3. 4 divided by 2 is 2. Multiplying across, we get 6x over a. Now, let's solve this linear equation. First, expand the brackets. 1510x equals 17. Next, we want to isolate the x term. Subtract 15 from both sides. Finally, divide by negative 10. Simplifying the fraction gives negative 1/5 or negative 0.2. When expanding brackets with a negative inside, like negative 10x, students often lose the sign when moving terms across the equal sign. Be extra careful with your negatives. Let's look at question 5. We have a composite shape, a trapezium ABEF, joined to a square BCDE. We are given that the area of the square is 32 square centimeters. Since the area of a square is side squared, we can find the length of side BE. Using your calculator, the square root of 32 is approximately 5.657. We will keep the exact form square root of 32 for now to avoid rounding errors. Next, we use the ratio AF to BE equals 3:2. This means AF is 1.5 times the length of BE. Using the calculator, AF is 8.485. Now we can calculate the area of the trapezium ABEF. The formula for the area of a trapezium is half the sum of the parallel sides, times the distance between them. Here, AF and BE are the parallel sides, and the base AB is 7 centimeters. Calculating this gives 49.497. Rounding to 3 significant figures, we get 49.5 square centimeters. In question 6, we need to convert 0.0473 into standard form. Standard form must be a number between 1 and 10, multiplied by 10 to a power. We move the decimal point 2 places to the right to get 4.73. Since we move the decimal to the right, the power is -2. Common mistake, forgetting that a small number results in a negative index in standard form. Always check if your original number was less than 1. Question 7 involves financial mathematics, specifically interest. In Part A, we calculate simple interest. The formula is interest equals principal times rate times time. The principal is $1,500, the rate is 2.16%, and the time is 4 years. Converting 2.16 to a fraction 13 over 6%. Using your calculator, 1,500 times 13 divided by 600, then multiplied by 4, gives exactly $130. In part, we deal with compound interest. The formula is total value equals principal times 1 plus r over 100 to the power of time. We are given the final value is 1825 and the time is 5 years. So, 1825 equals 1,500 times 1 plus r over 100 to the power of 5. First, divide both sides by 1,500. To solve for r, we take the fifth root of both sides. Subtract 1 from both sides. Finally, multiply by 100 to find r. Rounding to 3 significant figures. Rounding to 3 significant figures. Common mistake. Using the simple interest formula for compound interest problems. Always check if the question says simple or compound before starting. Question 8 covers map scales and bearings. To find the scale, we must use the same units for both values. Let's convert 365 kilometers into centimeters. Now we set up the ratio 7.3 to 36,500,000. To get the 1 in the 1 to n format, divide both sides by 7.3. Using your calculator, this gives 5 million. Next, bearings. The bearing of A from B is 70 degrees. To find the back bearing from A, we look at the parallel north lines. The interior angles between parallel lines add to 180, so the angle inside the north line at A is 110. However, bearings are measured clockwise from north. A quicker rule is, if the bearing is less than 180, add 180. The answer is 250 degrees. For this part, we need more angles. We know the bearing of A from B is 70, so the line AB makes an angle of 70 degrees with the north line at B. The bearing of C from A is 195. Since the back bearing of B from A was 250, the angle between the lines AB and AC at point A is the difference. Now we have triangle ABC with angles 55 and 113. We find the third angle, ABC. The bearing of C from B is the bearing of A from B minus this internal angle. The answer is 058 degrees. Common mistake. Forgetting to write bearings as 3 digits. 58 should be written as 058. Now we turn to page 8, starting with coordinate geometry, statistics, and linear graphs. Question 9 asks for the midpoint of P, 4, 10, and Q, -8, 5. To find the midpoint, we take the average of the x-coordinates and the average of the y-coordinates. For x, we have 4 plus -8 divided by 2, which is -4 over 2, or -2. For y, we have 10 plus 5 divided by 2, which is 15 over 2, or 7.5. The coordinates are -2, 7.5. For question 10, the data is already in order. There are 13 scores. Part A asks for the median. The median is the middle value, which is the 7th score. The 7th score is 34. Part B asks for the interquartile range. First, find the lower quartile, Q1, and the upper quartile, Q3. Q1 is the middle of the bottom 6 values. That is between the 3rd and 4th score, giving us 23.5. Q3 is the middle of the top 6 values. That is between the 10th and 11th score, giving us 41. The interquartile range is Q3 minus Q1, which equals 17.5. Question 11 concerns line L with the equation y equals 6x minus 1. In part A, find a line parallel to L passing through 0, 3. parallel lines have the same gradient, so m equals 6, since it passes through 0. 3. The equation is y equals 6x plus 3. In part B, we need the gradient of a perpendicular line. Perpendicular gradients are negative reciprocals. So, the gradient is -1/6. A common mistake when finding the interquartile range is that students often pick a value from the list rather than averaging the two middle points of the quartiles if necessary. Always check the position. On page 9, we have an inequality and some circle geometry. Question 12 asks us to solve -1 is less than or equal to 4 minus 2x, which is less than 8. To find the integer values of x, we solve the inequality in two parts or simultaneously. Let's subtract 4 from all parts. Now, we divide by -2. Remember, when dividing by a negative number, the inequality signs flip. So, x is greater than -2 and less than or equal to 2.5. The integer values are -1, 0, 1, and 2. Common mistake: forgetting to flip the inequality sign when dividing by a negative. This is the most frequent error in algebra. Now for question 13, on circle geometry. For part A, we find angle EAC. The angle between tangent FG and chord EA is 34 degrees. By the alternate segment theorem, this equals the angle in the alternate segment. For part B, angle ADC is found using properties of segments and the given angles. In this case, angle ADC is 89 degrees. For part C, ABCE is a cyclic quadrilateral. Opposite angles add to 180, so angle ABC is 105 degrees. Make sure to study the alternate segment theorem carefully, as it frequently appears in these geometry problems. On page 10, we are asked to find the three inequalities that define the unshaded region, R. First, let's identify the three boundary lines. The vertical line passes through x equals -4. The region R is to the right of this line, so the inequality is x is greater than or equal to -4. Next, let's look at the dashed diagonal line. It passes through the origin point 0, 0 and the point 1, 1. This is the line y equals x. Because the line is dashed, the inequality is strict. The region R is above the line, so y is greater than x. Finally, let's find the equation of the solid downward sloping line. It crosses the y-axis at 2, so the intercept c is 2. It also passes through the point 4, 0. The gradient m equals 0 minus 2 over 4 minus 0, which is -0.5. So the equation is y equals -0.5x plus 2. Multiplying by 2 to clear the decimal gives 2y equals -x plus 4, or x plus 2y equals 4. The region R is below this solid line, so the inequality is x plus 2y is less than or equal to 4. So, our final three inequalities are x is greater than or equal to -4, y is greater than x, and x plus 2y is less than or equal to 4. A common mistake is using the wrong inequality sign for above or below. A good trick is to pick a point inside the region R, like -1, 0, and test it in your inequalities to make sure they work. Moving on to page 11, we have functions and the quadratic formula. We are given two functions, f of x equals 2x squared minus 3x, and g of x equals 7 plus 2x. For part AI, we find g of -8 by substituting -8 into the function g. 7, 16 equals -9. In part 2, we find the composite function g f of 5. We work from the inside out. So first, find f of 5. Now we put this result into g. 7 plus 2 times 35 is 7 plus 70, which is 77. For part 3, we find the inverse function of g. Let y equal 7 plus 2x, then rearrange to make x the subject. So, the inverse function is x minus 7 over 2. In part B, we find f of x minus 6. We replace every x in the original f of x with a bracket x minus 6. Expand the square first. x6 squared is x squared minus 12x plus 36. Now collect like terms to get 2x squared minus 27x plus 90. Finally, part C asks us to solve f of x minus 6 equals 0 using the quadratic formula. Using a equals 2, b equals -3, and c equals -6, we plug them into the formula. This simplifies to 3 plus or minus the square root of 57, all over 4. Calculating the two values to two decimal places, we get x equals 2.64 or x equals negative 1.14. A common mistake when substituting into the quadratic formula is forgetting that b squared is always positive. Negative 3 squared is 9, not negative 9. On page 12, we work with group data and histograms. Tina has data for 120 apples. The data is provided in this table showing mass intervals and their frequencies. For part A, we estimate the mean. We need the midpoints of each class interval. Now, multiply each midpoint by its frequency and sum them up. Divide the total mass by the number of apples, which is 120. The mean is 220, 5.5 grams. In part, we draw a histogram. Remember, for histograms with unequal class widths, the vertical axis is frequency density. Let's calculate the density for each bar. 0.6, 0.7, 1.3, and 0.3. We draw bars with these heights and corresponding widths on the grid. Moving to page 13, Part I asks for the probability an apple is 180 grams or less. There are 18 such apples out of 120, which is 0.15. Part I is more complex. 2 apples are picked from those greater than 180 grams. First, there are 102 apples in that range. We want one over 270 grams, which there are 9 of, and the other 220 grams or less, where there are 28. There are 2 ways this can happen. We multiply the probabilities and sum them. Using the calculator, this is approximately 0.0489. Common mistake. In probability, forgetting that when picking one of each, there are usually 2 different orders to consider. Also, remember to decrease the denominator for the second pick, since the first apple isn't replaced. Question 17 takes us to a football pitch, which is basically a problem involving non-right-angled triangles. In part A, we need to show that angle CAD is 86.2 degrees. Look at triangle ACD. We know all 3 sides. AC is 18, CD is 20, and AD is 10. To find an angle when we have 3 sides, we use the cosine rule. Let's rearrange it for the angle. Calculating the values, we get 24 over 360. Taking the inverse cosine, we find that CAD is approximately 86.2 degrees. For part B, we need the obtuse angle ACB in triangle ABC. Here, we know side AC is 18, side AB is 35, and angle ABC is 27 degrees. Since we have an opposite side angle pair, we use the sine rule. Rearranging gives sine of ACB equals 0.8827. Using inverse sine, the calculator gives 61.97 degrees. Wait, the question specifies an obtuse angle. The obtuse angle is found by subtracting from 180, giving us 118.0 degrees. Finally, part A asks for the average speed of a player running from B to D. Speed is distance over time. We have the time, 5.3 seconds, so we need the distance BD. Angle BAD is the sum of angles BAC and CAD. We first calculate angle BAC to be 34.97 degrees. Then, BAD is 121.147 degrees. Now use the cosine rule in triangle ABD to find distance BD squared. This works out to 1686.9, so BD is the square root, which is 41.07 meters. Dividing distance by time, we get the average speed as 7.75 meters per second. A common mistake occurs in part B. The calculator will always give the acute angle. You must remember that sine of x is also positive for 180 minus x. If the diagram or question says obtuse, you must subtract from 180. We are now on page 16, dealing with proportionality and bounds. Question 18. F is inversely proportional to the cube of g. In part A, we translate this relationship into an equation. Inversely proportional means we use a constant k divided by the variable. We are given that when f equals 0.5, g is 3. Let's substitute these to find k. K equals 0.5 times 27, which is 13.5. So, the equation is f equals 13.5 over g cubed. In part B, g is increased by 100%. Increasing by 100% is the same as doubling the value. So the new g is 2g. Let's see what happens to f. The new f equals k divided by the quantity 2g cubed, which simplifies to k over hg cubed. The new f is 1/8 of the original f. Percentage change is new minus old, all over old, times 100. 1/8 minus 1 divided by 1 times 100 gives negative 87.5%. So the answer is an 87.5% decrease. Question 19. The area of a triangle is 12 square meters to the nearest integer, and the base is 5.7 meters to the nearest 0.1. We need the smallest possible height. The formula for height is 2 times area divided by base. To make the height as small as possible, we need the smallest possible area and the largest possible base. First, find the bounds. The lower bound for the area is 11.5. The upper bound for the base is 5.75. Now substitute these into the formula. Smallest height is 2 times 11.5 divided by 5.75. Using your calculator, this equals exactly 4. Common mistake. Forgetting that to minimize a fraction, you must minimize the numerator, but maximize the denominator. Students often use the lower bound for both. This is a test scene to check the camera setup and text rendering. And here's a basic circle as a graphic.